Good morning, good afternoon, good evening, depending what time you're watching this video. I'm Dr. Giorgio Chianello from Queen Mary University of London, where I am a lecturer in chemistry. In this set of video, we're gonna be looking at analytical chemistry techniques. In this video, we will explore melting point. So what is melting point? Simply is a temperature range at which a solid, a substance, melt. Now, why am I saying a range and not a specific temperature? Because in reality, the melting point is never an individual value. It's a range of temperature. And when we analyze melting point, what we look at, so we increase the temperature and we look closely at a solid. And we look when the first drop of solvent forms, that is going to be the first temperature we record, and when the whole solid is completely melted. That's going to be a different temperature, so a bit higher. So that's the reason why I'm saying range and not specific temperature. But why melting point is so important? So what's the point of melting point? Pun intended. So melting point gives us an indication of how strong are intermolecular forces within a solid, meaning how tightly bound are molecules within a solid. So the higher the melting point, the stronger are the force between molecules. So meaning that in order to separate these molecules, we need more energy. We need to provide a lot of energy to the system to put these molecules apart and then transform a solid into a liquid. So a more disorganized, if you wish, state of matter. So what is important? So why is important? What can we do with this? It's very simple. It's a very simple technique. It might seem something that is not very relevant. In reality, melting point is a key parameter. It's very, very important because it can tell us how pure a compound is and can easily help us identify a specific compound out of a series of compounds that look very, very similar. How do we measure it? Simply, we have an apparatus that increases the temperature very slowly, and we monitor, we can look at the solid as the temperature increases. And again, as we said before, what we are looking at is this temperature range, the first drop that is formed when the whole solid has become liquid. So the apparatus I'm talking about is sitting right next to me. It's this machine here. Nothing very complicated or fancy. You see, there is a little lens here that allows me to look through a sample. And the amount of sample that we need, the amount of solid, of substance that we need is very, very small. So what we do, we have to take a capillary tube that is a very small glass tube that is open on one end and closed on the other. We put a little bit of powder into this capillary tube, and we end up with something like this, very, very small, with small amount of powder. What we do with this capillary tube, with our substance, we place it inside this instrument, we start the instrument, the temperature rises up, and again, we observe through this lens the change of the state of this substance from solid to liquid. And this is how we record this value, so the melting point. But as we said, this is also an indication of how pure a compound is, or is also an analytical technique to discriminate molecules within a set of molecules. So how can we measure purity of a sample? So purity of a sample, again, every molecule will have its own specific melting point range. So we have, for instance, sugar in here. Okay, what is the melting point of sugar? Melting point of sugar is tabulated. Depending on what sugar it is, it might range between 100 and 180 degrees. There are different kinds of sugars. Okay, let's say we are looking at fructose. Fructose is around 110 degrees. Fine. We place this sample inside the melting point apparatus, and if what we see is a range between 105 and 115 degrees, then we are sure this is fructose and it's quite pure. However, if this range is off, is either too high or too low, or both, so actually this range is very, very large, this is an indication that our compound is not pure. Because when there are contamination each compound in our mixture will have different melting point, and therefore this will affect the overall range, either lower melting point, higher, or again, both, depending what are the contaminants. And this is one application. It's also good, for instance, in this case, when we perform a reaction in a chemistry lab, what happens is we produce a product, and we want to see whether the product we have produced is pure or not. This is an excellent technique, very quick, very inexpensive, to verify whether our product is pure. The other side of the medal, of the coin, if you wish, so we can also discriminate between a set of unknown compounds that look very, very similar. Let's look at this image in here. As you can see, all these different molecules, they look very, very similar. They are all white solids. So, for instance, we have two different kinds of sugar, as we said before. So, fructose and sucrose, which is essentially table sugar. As you can see, they have very different melting point. So, around 103 degrees, around 186 degrees. Then we have sodium chloride, very, very high melting point, 800 degrees. Aspirin, which I'm sure all of you know, is a little molecule that you take when you have fever symptoms. And triacontain, this very weird name molecule that is actually very common, is contained in most of the candles or any products, any cream that you use for skin care, or like shampoos and so on and so forth, or also caffeine. As you can see, they're all white, but all their melting points are extremely, extremely different. So you may argue, for instance, when you're cooking, sometimes you have two jars in your kitchen, one with sugar, one with salt, and sometimes they are not labeled, and you are wondering, so which one is which? And one simple way is, of course, you taste them, and you immediately realize that one is sugar, one is salt. But of course, you have to imagine that in a chemistry lab, you cannot do that. Some of those molecules can be actually quite toxic and can be very harmful. So a melting point apparatus is an excellent tool for us to discriminate between these molecules without having to taste them. So I hope you understand now how important melting point is as a technique for a chemist or a scientist in general. In the next video, we're going to be looking at another technique, a bit more complex, but probably a bit more challenging, and that is chromatography.